In building the unit circle, our first step is going to be placing the various angles on the unit circle. Okay, so if you flip back to page 1 and you look at the complete unit circle, you can see there's a whole lot of angles on the unit circle. So we're not going to put all the angles on there at once. We're going to do this gradually. Okay, so let's take a look at the top of page 2. We are going to start by talking about angles that are multiples of pi over 3. Okay, so again, I've already told you that with all the angles on the unit circle, you have to know both the degree measure and the radian measure. Okay, so I'm kind of presenting this from a radian perspective. We will put the degrees on here as well, but I want you to start thinking in terms of radians. When you are in trig, about half your angles will be in degree measure, half your angles will be in radian measure, and then as you move up the math chain, you're going to see more and more of radian measure. By the time you get to calculus, I'd say almost all of your angles are going to be measured in radians. Okay, so you really need to start thinking along those lines. Okay, so again, our focus for this particular picture is going to be on angles that are multiples of pi over 3. Okay, so let's think about this. What have we learned so far in this class? Okay, we know that when you're dealing with any circle, not just the unit circle, one revolution is equivalent to 360 degrees, okay? And we've already learned that 360 degrees is equivalent to 2 pi radians, okay? So if we only look at half the circle, so if we do a half a revolution, okay, we cut all of this in half. We know that half a revolution is going to be 180 degrees, and that's equivalent to pi radians, okay? So when I look at this particular circle, and we can pretend, that this is the unit circle, what we're going to do here, I am going to look at a half circle to start, okay? So we're going to look at the top part of the circle, okay? We're going to start building angles. So remember, every angle on the unit circle has to be in standard position, meaning the angle has to have its vertex at the origin, okay? And the initial side of the angle has to lie along the positive x-axis. Okay, so I'm going to go ahead and put that on here. Here's the initial side of any angle on the unit circle. Okay, it has to coincide with the positive x-axis. Okay, so there we go. Okay, all right, if you go back and you look at the complete unit circle, all the angles on there are positive. So that means when we rotate, the rotation is going to be counterclockwise to get those positive angles, okay? All right, so like I said, we are going to be dealing, I'm just going to focus right now on half a revolution of the circle. So since we're going to rotate counterclockwise to get positive angles, I am going to focus on the top half of the circle for right now. Okay, so that's where we're going to be focused, and then we'll deal with the bottom half. Okay, all right. So we know, okay, that this top half, half a revolution, should be 180 degrees. Okay, so here's what I want you to do. Okay, this is your starting point. Okay, your starting point is, coinciding with the positive x-axis. That is going to be considered 0 degrees slash 0 radians. Okay, don't interpret the slash as division. Okay, I'm just putting degrees and radians on there. So your starting point, you have to start somewhere. Okay, we're starting, our starting point coincides with the positive x-axis. That's considered to be 0 degrees or 0 radians. Okay, and so then we know that if we take this starting side and we rotate half a revolution, that should bring us to 180 degrees, which is the same thing as pi radians. Okay, so I'm going to go ahead and put that on here. Okay, so if you were to rotate half a circle, okay, that would bring you here. Okay, so there you go. All right, so that's what we know. That's what we've learned so far. Okay, so the top half of the circle, okay, this angle, okay, if you rotated from the initial side and you rotated half a revolution, that's 180 degrees or pi radians, okay? Like I said, let's focus on the radian measure, okay? So half the circle, the top part of the circle, there's pi radians. So if we are focusing on pi over 3, we're going to take that top part of the circle, which has pi radians, and we're dividing by 3. So that means we're breaking the top part of the circle into 3 equal pieces. Okay, so let me repeat that. Okay, the top half of the circle consists of 180 to 80 degrees or pi radians. Okay, since we're looking at multiples of pi over 3, we're taking that top half of the circle and we're breaking it into 3 equal pieces. Okay, so watch what I'm going to do. Okay, so I'm going to take this off so we get some room here. Okay, I am going to break the top half of the circle into 3 equal parts. Okay, so I'm going to do that. All right, so here we go. Again, when I'm doing each of these angles, remember they have to be in standard position. Okay, so I'm considering, well, let me back up here. I'm considering my start place to be right here, okay, at the coinciding with the positive x-axis, and then I rotate counterclockwise, okay? So here I go, okay? I'm breaking it into 3 equal pieces. Okay, so here's gonna be the first part, okay? And then I'm gonna do it again. Okay, so I'm align it with standard position, rotating, okay? So here we go again, and there we go. Okay, so what I have done, okay, we have broken the top part of the circle into 3 equal pieces. Okay, so I will actually color code them for a second. So I'm going to pause the video and kind of color them in so you can see the 3 different pieces, and then I'll resume the video. Okay, so I've added some color here, so hopefully this can help you see that I've taken the top portion of the circle, which contains pi radians, and divided it up into 3 equal pieces. So you can kind of consider each of these pieces to be pi over 3, okay? So what we're gonna do here is we're talking angles. We're measuring angles, okay? So let's show the angles here, okay? So let's look at our first angle. Okay, each angle is going to be in standard position. So for our first angle, the origin will be at the vertex. The initial side will lie along the positive x-axis, and then we're going to rotate counterclockwise, okay? And we're going to rotate pi over 3 radians, okay? So this angle right here, okay, this angle is pi over 3 radians, okay? Because we went the length of basically the entire pi divided by 3, okay? And so that particular angle where the terminal side leaves off, that is an angle of pi over 3 radians, okay? So now for the next angle, I'll put it in a different color, okay? Again, if we start in standard position, so origin at the origin is the vertex, okay? Positive x angle, that's our initial side, okay? And we start rotating counterclockwise, okay? We go pi over 3, and then we go another pi over 3 to end up here, okay? This angle, okay, right here, here's where the terminal side leaves off. This angle, we went 2 times pi over 3 radians, okay? So this particular angle right here, okay, with this initial side and this terminal side, it has a measure of 2 pi over 3 radians, okay? All right, and when we do it again, okay, so for my next angle, okay, again, the vertex is at the origin. The initial side coincides with the positive x-axis. We're going to rotate pi over 3, another pi over 3, another pi over 3. Okay, so to go from this initial side to this terminal side, okay, our angle, we went 3 times pi over 3 radians. We did it 3 times, okay? So that gives us 3 pi over 3. That simplifies to be pi radians, okay? So this particular angle has a measure of pi radians, which we expected, okay? So there are 3 of the angles so far. We saw where the pi over 3 comes from, 2 pi over 3, and the angle pi itself, okay? Now you can keep doing this, okay? We did this to the top half of the circle, okay? you can do it to the bottom half of the circle as well, okay? So what you could do here is you can continue on. You can take the bottom half of the circle, okay? The bottom half of a circle is still the half a circle. So the bottom half of the circle will also measure 180 degrees or pi radians, okay? You can break it up into 3 equal parts, okay? So if we did that here, okay, start with your initial side, okay, rotate around counterclockwise, okay, that would bring us here, okay? All I'm doing is breaking the bottom piece into 3 equal parts, okay? So there's another one, okay? Let's do it again, okay? So get in standard position, rotate around, okay? So here's another piece, okay? And then the last one, so we're doing the full circle here, okay? Get in, here's your initial side, rotate around, okay? This time we end up going the whole length of the circle here, okay? So that brings us back kind of to the initial side, okay? So that is gonna bring us back into, 3 additional pieces here, okay? So I'm gonna go ahead and color code those as well. All right, so I have again taken the bottom half of the circle. Bottom half of the circle also contains 180 degrees or pi radians. I've broken it up into 3 equal pieces, so you can kind of think of each of those sectors as pi over 3, okay? And so now I'm going to continue with my angle measure, okay? So we have already looked at the angles of pi over 3, 2 pi over 3, and 3 pi over 3, which is pi, okay? So now, again, to get my next angle, I'm going to start, vertex is at the origin. My initial side will lie along the positive x-axis, and I'm going to rotate counterclockwise. So we're going to go 1 pi over 3, 2 pi over 3, 3 pi over 3, and then when I get here, this will be 4 pi over 3. Okay, and then you just keep going. Okay, so we do this again. Okay, so my next angle, okay, start in standard position. Okay, 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. That brings us to a terminal side of right here. This angle will be 5 pi over 3. Okay, and then lastly, okay, again, start in standard position one more time. Okay, this is going to be 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. This will bring us to 6 pi over 3. And we've swept out the entire circle, okay? And so 6 pi over 3 reduces to 2 pi, which makes sense because we went the entire circle, okay? And every circle, one full circle should be 2 pi radians, okay? So that is what if you go one time around the circle, okay, if your angles are multiples of pi over 3, that's what they look like, okay? So we could go back and look at the degree measures here, okay? There's a couple of ways you can think about this. The first angle we made was pi over 3 radians. If you converted that to degrees, okay, remember the conversion factor? If you're trying to get radians to go away, you would put radians in the bottom, okay, and you would put degrees in the top. And so we know that 180 degrees is the same thing as pi radians. So if you multiplied across the top and across the bottom, what would happen? Well, the radians would cancel, the pi's would also cancel. That would leave you with 180 degrees divided by 3, okay? And that's telling you that pi over 3 is equivalent to 60 degrees, okay? So that first angle, okay, it's, you can think of it as pi over 3 radians or equivalently 60 degrees, okay? Why does this make sense? Okay, well, you could have also looked at this, well, we took the top half of the circle, okay, which has 180 degrees, and we divided it into 3 equal pieces, okay? So each of these angles on their own would be 60 degrees, okay? So that makes sense, okay? So then if you rotate it around here, okay, you could convert each one of these radian measures to degrees, but that's a pain. So you could just simply look at each of these as being 60 degrees, okay? So for this first angle, we had our initial side, and then we rotated to our terminal side, that would be 60 degrees. So when we did the second angle, okay, we would go 60, and then 60 times 2, that would be 120 degrees right here. And then if we rotated half a circle here, this would be starting here, there would be 60, 120, this would be 180, which we already know, okay? And then if we went down here, okay, again, start in standard position, where if you follow my little cursor there, we're gonna go 60, 120, 180, add another 60 degrees. That's gonna give us 240 degrees, okay? And then again, okay, so 60, 120, 180, 240, add 60 degrees. So when you get to 5 pi over 3, that's 300 degrees, okay? And then lastly, all the way around the circle, it'll be 60, 120, 180, 240, 300, add the final 60 degrees. That brings you to 360 degrees, okay? Which we also know that there are 360 degrees in a full circle, okay? Also realize here that 0 degrees, which is 0 radians, that is coterminal with 360 degrees or 2 pi radians, okay? Those angles have a different amount of rotation, but their initial sides are the same and their terminal sides are the same, okay? So here's where we're getting these particular angles from, the angles that are multiples of pi over 3. Okay, so basically all we did to get these, okay, just to recap, we know that half a circle, the top half of the circle, contains pi radians. So we divided the top half of the circle into 3 equal parts. We did the same thing to the bottom half of the circle, okay? So each of these little sectors you can think of as pi over 3 or 60 degrees, okay? And then we just started rotating counterclockwise, okay? And so that gave us the different measures: pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3, okay? And then we looked at the equivalent degree measures, okay? All right, so the next thing we're going to look at is, in the same fashion, we're going to look at the angles that are multiples of pi over 4.